Welcome for day 2 of API Days Interface. We had a great day 1 with a lot of interesting topics. As a keynote, we had a great discussion with Eric Newcomer, author at the New Stack and CTO of many different companies in the past in the API industry space. Talking about the latest trend, like this trend of the API management industry, the API security industry and focus, privacy regulations involving APIs. We talk about event-driven architecture. We talked also about the no-code and low-code strategy right now involving, of course, APIs in large organization. And we also talk about the LLM frenziness, like the large language models, all these AI APIs that are actually changing the way we build software or we build customer experiences. We had also Yannick Tremblay from Rocher, who are presenting the API Green Score. A new way to think sustainability into your APIs, by new metrics, new way to monitor API consumption and resource consumption, but also like many good practices to reduce the carbon footprint of your software and your APIs on the UX, on the code, on the architecture, and on the hardware. So that was extremely interesting. And then we have 3 tracks. One track dedicated to AI and LLM, right, where we talk about like how to consume these AI APIs and how to be sure that maybe your APIs are connected with them to mix your data with LLM capabilities to actually generate new customer experiences. Or maybe if you want to do a plugin, so you can appear in the search results or in the prompt of LLMs. We had also another track about the new stack of API management. So where we're talking about like the new tools, the new practices, the new methodologies that actually enable you to rebuild and refactor your company with APIs and with API management. And we had the third track on API security with our partner API Sec University, where we talk about the new challenges of API security, from new threats, new attacks, new ways to defend, and how to deal and to cope with all these shadow APIs that company have too much, and that we really need to monitor. First, to observe, to discover, then to monitor and control, and then to really secure. For today, we'll have 2 tracks. One track really on API lifecycle and API lifecycle management, and one track on API as a product and, let's say, business driven by APIs, right? So that will be the 2 tracks we will have today. And just a reminder for the people who were not there yesterday, but about API Days, just to be sure why we're here. We're here to connect the humans behind APIs, the humans behind the interface that are produced and built. We consume APIs from each other, but when do we talk? This is why API Days is made for. So we've done that since 2012, and when we do that in 8 different countries every year, plus 1 digital event. And you are part of this digital event right now called API Days Interface. But you can look at us and come to our in-person event, either in New York, London, Paris, Dubai, Helsinki, Hong Kong, Singapore, or Australia. So if you love the online experience, great, you're at the right place. If you also love in-person experience, you can meet us in one of these events. And just to give you some hints, after 11 years of existence, it's more than 75 events, more than 70,000 past attendees for 2,000 speakers, right? We really had everyone, every thought leaders in the community as a speaker. So don't hesitate. If you want to apply to speak, you can go on our website too. Just to make some noise, the hashtag of the event is API Days Interface. If you want to connect with each other, if you want to tweet about it, great screenshot, great discussion, great quotes. API Days Interface is for that. And if you want to mention us at API Days Global, we will be glad to retweet you or to mention you. We also want to thank our sponsors, Influx Data, great analytics platform and a database company, right? The data company. And also our browser and community sponsors like Kong, Blobber, or Traffic Labs, who makes this event possible and free online, thanks to them. So yeah, they have booth on the platform, so don't hesitate to look what they're doing. They are probably the product you need for your API management strategy. But for now, we will start the conference with a guest, with a Kostas Korakitis, who will talk with us and present latest research about developers' take on what makes up a high-quality API. Hi, Kostas. Are you able?
Hi, Mehdi.
Yeah. Hello, Kostas. How are you
Hello.
doing?
Good morning. I'm doing well. All right. Okay.
Yeah. SlashData is known as a great research company, for developers. So we're really glad to have you. And let's discover what you have for us.
All right. Okay. So as you say today, I will talk about like developers' view on what makes it up a high-quality API. So here's the agenda for today's keynote, and so first I will give an overview of how the adoption of APIs has evolved over time, based on data we collect through our global developer surveys. Then I will focus a bit more on the main ingredients of a high-quality API. That's from a developer's perspective. And finally, I will give you some interesting insights in terms of like which factors are more likely to affect developers' views and perceptions towards API quality. All right, so at SlashData, we've been tracking the adoption of public or third-party APIs for quite a while now, nearly 3 years now, through our biannual global developer surveys. And what we have been observing is that the growth, there's a steady growth in the proportion of developers who report consuming third-party APIs. That's from 67% at the beginning of 2021 to 74% 2 years later. And if we account for another 15% of developers who report using only internal or private APIs, then we find that like nearly 9 out of 10 developers rely on APIs to access pre-built features and functionalities for their applications. So, and also the use of third-party APIs is widespread across many different sectors of the developer economy and across various developer segments. And for example, we find that even the adoption from 74% goes up to nearly 85% among early career professionals, that those with 3 to 5 years of coding experience. Okay, however, not all APIs are created equal. Right, as with any product and service, APIs are offered at varying levels of quality, as measured by aspects like their reliability, their scalability, security, consistency across endpoints, and many more things. And I'm sure that each and every person actively involved in the API industry, in the ecosystem, will have their own opinions about what contributes to a successful API implementation, but who are more like in a better place to tell than the users themselves. That's the developers. And here's what they told us in SlashData's latest global developer survey, the one that closed in Q1 of this year. So the most important characteristic of a high-quality API is actually security. So with malicious attacks becoming more common and more sophisticated over time, and with more regions and more countries and more regions adopting stricter data protection and privacy standards, it's really no big surprise that security is a top priority for developers when they look for an API to integrate into their applications. Moving down the priority list, we see here we find a group of important characteristics that are mentioned between 36 and 39% of developers. These include documentation and sample code, reliability, which refers to the ability of an API to perform consistently over time with no downtimes, error, or crashes, ease of use, performance, and performance. So there's also a very long, it's a quite long list of API characteristics that are mentioned by up to a fourth of all developers, including technical support, scalability, community, and so on. Overall, developers report on average about 4 characteristics that contribute to a successful API, which really goes a long way to say that that developers have really high expectations from API providers. And if we look at those who reported just a single characteristic, just one thing that for them makes an API high quality, security comes again at the top, and this time with a really significant difference from the others. Therefore, security is an API aspect that developers don't compromise on. All right. So now looking at a broad categorization, let's say, of API characteristics that result in successful implementations. So if we group them into technical and non-technical, we find that nearly all developers, that's 96%, mention at least one design-related attribute, such as security or performance. So this is really a very important message for API providers that your technical design choices have a huge impact on how developers perceive your product. That's however not to say that non-technical decisions don't matter. In fact, they matter a lot, and 78% of developers report at least one non-technical attribute that leads to successful or high-quality APIs. With the most important of all being of course, like documentation and sample code, which is something that we will dive deeper into very shortly. Okay, so the big picture of what is or what makes up a high quality API is interesting, but it is also very important to go one level deeper and to understand how perceptions towards API quality change across different developer profiles. And this is important because it can help like API providers to better target like developer segments with the right features and also the right messaging. First of all, I have to say that there are several factors that really have no or small impact on how developers perceive various characteristics that contribute to API quality. So here, just to name a few, starting from the types of projects that developers work on. What we mean here is that things like API security or reliability or ease of use, these all remain very important aspects, very important expectations from developers, regardless of whether they build like a backend service or a mobile application or a game application. So we don't see any significant differences based on what they're working on. And same applies to the categories of third-party APIs they use. And by categories, we mean things like payment APIs, authentication, email APIs. So any type, like all these categories that the developers may be working with. So from all these categories, developers have pretty much like the same expectations. The importance doesn't change a lot. And similarly, so we see the same pattern with their role, the size of the company that they may be working for, the way they find information about software development, the way they consume content. So for all these factors, we actually see very small or no variations in the importance of the various API characteristics. But there are some other dimensions that exhibit some significant differences, and here's what we will see next. So here we will start with the developer's experience in software development, which we find is one of the key differentiators as to how developers view, as to how they perceive the importance of the various API characteristics. So the most remarkable example here is documentation and sample code here with the blue line. The importance of this aspect actually rises astronomically with coding experience. So only 20% of beginners in coding, in software development, think that documentation and sample code is an important characteristic of a high-quality API, as compared to about 65% of the seasoned developers with 16 or more years of experience, of coding experience. And this makes sense, as those new to software development tend to work on less challenging problems, and are also more likely to turn to their peers for help and support, which is also seen in the importance of that it plays on the community here with the green light. The community formed around an API. That's as compared to the more experienced peers, since they view this community as a way to learn and get support. Right. So highly experienced developers work on more complex projects and the more challenging projects, and therefore, as such, they appreciate the benefits of world-class documentation and sample code. They similarly have like a deeper appreciation for reliability, since it's likely that they build and maintain systems and applications and systems that are accessed by hundreds of thousands or even millions of users daily, on a daily basis, and therefore they find it critical that they use components that are reliable and highly available. So important is also that they use APIs, they use tools that utilize architectural styles that are well established, and therefore they can be therefore they are familiar with these technologies and these architectural styles, which improves the developer experience, reduces the learning curve, and at the end, ultimately, it accelerates the development cycle. Finally, we see here at the bottom, portability, API portability is something that matters more to the less experienced developers, as they are less likely to have like ingrained preferences towards certain technology vendors or cloud providers. And as such, they appreciate the flexibility of moving their API from one vendor to the other. Okay, so I briefly mentioned world-class documentation in the previous slide, but how is this really defined? In other words, what are the main aspects, the main ingredients of a great documentation, according to developers? So here we see how the two opposite ends of the experience spectrum, that's beginners, those with up to 2 years of experience on one side, and seasoned developers, that's those with 11 plus years of experience, view the quality in API documentation. And one clarification here is that in our last survey, we asked about the importance of 16 different characteristics of documentation, but here we see only the ones that show the larger differences between these two experience groups. All right, so starting from here, we find that the majority of seasoned developers really appreciate that the documentation is accurate and up to date, and also that it contains specific examples. These are very important characteristics, and in fact, we find that these very experienced developers are, in fact, about twice as likely to value these aspects than those who are new to software development. They also, the experienced developers, highly experienced developers, are also considerably more likely to think highly of the documentation that's well written, meaning that it's very clear, that's concise, unbiased, and also documentation that is easily searchable, right? On the other end of the spectrum, looking at what is the entry-level developers value more than their experienced peers, we see that these beginners in software development value translations into their own language, but also community contributions and offline availability. All right, so moving on with the key factors that affecting developers' perceptions towards API quality. here we see how these preferences, how developers' preferences also change based on their geographic location. A first important observation here is that regardless of the specific characteristics, API characteristics, developers in certain regions are seem to be more demanding or have higher expectations when it comes to API quality than in others. For example, we're looking here, so Eastern Europe and Oceania, we find that in these regions, developers mention on average about 4.5 characteristics that contribute to a high quality API, as compared to about, for example, 3.5 in the regions in Asia, so South Asia and East Asia, including Greater China. A second important remark is that security, which we see with the light blue line here, is a top priority for developers, almost in many regions, but is of particular importance in Europe, that's Western and Eastern Europe, and Oceania. This is likely a consequence. This is likely driven by the quite strict data privacy and protection standards and legislation that these regions have in place. So also developers in these regions, again, Europe and Oceania, but also North America, have a higher appreciation for documentation and sample code than for security, which is really a direct consequence of the very high concentration of highly experienced developers in these regions. So we saw before the very strong correlation between experience and appreciation for good documentation and sample code, and here we see that the regions which have have a very high concentration of such developers, seasoned developers, also value documentation a lot. And just to give you a quick stat, we find that at least 20% of developers in these regions that I mentioned, Europe, North America, and Oceania, have 16 or more years of coding experience, as compared to about 10% of developers in the other areas. So a much higher, like an overrepresentation of very experienced developers. All right. So finally, whether developers make use of no-code or low-code tools is also likely to affect how they think about the quality of APIs. As we all know, APIs were originally designed to be used, to be consumed by developers, by software developers who can code. But really, as years go by, and with increasing adoption of cloud and web applications and software as a service by business users, we also see that the need for the interconnection of these services, of these products, also increases, and these business users that may know how to code, but also may have limited coding experience, or they may not to code at all. For them, it's important that they have an easy and intuitive way to interconnect these applications. And here's where all the no-code and low-code platforms come into play. And nowadays there are many such tools and many such platforms that enable these business users to build workflows and entire applications using existing APIs. So for those users, the things like API documentation and the ease of use of the API itself really don't matter as much as for those not using no-code, low-code tools. You can say programmers, right? So because these no-code and low-code tool users are not very likely to write code. I mean, they may write it, because by using no-code and low-code tools, we really mean in some cases on top of traditional coding tools. But for those users are not as likely to write code, and as such, they don't interact with APIs directly. So that's why this appreciation of documentation and ease of use and well-established architecture styles is not as important. What matters to those users, though, is that vendors provide proper technical support or good technical support in case they have issues, in case issues arise that are hard to resolve or even diagnose without expert level knowledge. And similarly, they care more about the community around the API and also the portability between different environments. And this is also, as I mentioned before, with the case of the regions, this is also somewhat linked to the experience in software development in general, because again, we find that those who report using no-code and low-code tools in our surveys, we see that they're considerably less experienced than those who don't use such tools, and therefore we see the connection with like wanting to have support from a community, and also the need to have a portable solution to move between environments in cases where they don't have very strong opinions yet on what to use. And yeah, and this concludes my presentation. For any API creators and API builders and users out there, our latest global developer survey is live at the moment, so feel free to take it.
Thank you very much, Kostas. Thank you for all these details. So today, there's a question about like what is, to your mind, what has the most impact on developers, according to the survey?
Yeah, so so obviously we asked about what we think leads to a high quality solution, right? But judging from their answers, and although we didn't ask them directly, okay, well, what do you think has the biggest impact? But I would assume that again, the things that the aspects that we saw at the top are also the ones that are likely to impact an API the most. Like, for example, security. If an API is not secure, we all know the catastrophic impacts that it can have to a product, to a solution, to a service. And also same goes with its reliability. If it's a critical application that experiences downtimes and errors and crashes, also performance. So I think the things that developers consider as leading to a very successful and high quality implementation are also likely to have the biggest impact in their product and the solution that they build.
Yeah, we have also a question about like let's say the age of developers. Do you see a clear difference between, let's say, junior developers and long-time developer, like really senior?
Yeah, so age and experience actually go hand in hand, as you can imagine, right? So this is like a very clear trend that we have seen over time, that the younger developer is, the less experienced they are, and vice versa. The older developers tend to be like more experienced. And as we saw, we saw some very clear differences in terms of experience. And we saw the aspects, the characteristics that are affected the most, with the documentation being like the one that shows the biggest differences between the beginners and experts.
Yeah, totally makes sense. Also, like, do you have anything about the no-code aspect, right? About the no-code, like, do you, in your survey, do you identify people who do no-code as developers or no?
Yes, actually, in terms of like a specific question that we have, where we identify like no-code and low-code users, there we our question is really structured in a way that okay, one option is I don't use no-code, low-code tools, and then we try to understand the extent to which they use these tools, and we have like things like up to 25% of my time, or up to like 25 to 50%, and so on and so forth. So what we see, for example, is that just to give you like an interesting finding, is that over time, over the last I would say 12 months, the use of no-code, low-code tools has increased. So 1 year ago, it was about 50% of developers who said that used no-code, low-code tools at least for like a part of their development work, but this has gone up to 60%. So it's not that developers are now like fully adopted low-code no-code tools, but at least for some aspects of their development workflow, they do utilize these tools. But still, it's only, I would say, a very small percentage. That's, I think, about 4 or 5% that they say that I use these tools for like more than 70% of my time. So we're not there yet. We're not there like at a stage where these tools have like have dominated, let's say, the software development ecosystem. But we see a clear like increase in their adoption.
Perfect. Thank you very much, Kostas, for answering the question, and thank you for the presentation with these quite really good insights.
Thank you. Thank you, Mehdi.
And so we'll continue with a talk that is really original. This is why we selected it to be one of the opening talks, about nuclear rust by John Darrington. So hello, John, how are you?
Good morning. How are you?
Doing well. Really glad to have you here. Just to let you know, as a apidays, as a conference, we organize the Digital Sustainable Challenge. You know, it's every year for 3 months. We ask the community to refactor their application or design according to eco-design principles, you know, architecture and stuff.
Mm-hmm.
And also we received the Shift project, the Green Software Foundation. So we really try to make our community aware of what's going on the green software. But like now it's in your proposal, we really love the fact that, yeah, you say, okay, but like how software can help, you know, like energy or production or energy sources or whatever to be developed with digital twins. And we're really interested by what you have for us. So the stage is yours for 25 minutes, and we look forward to it.
Awesome. Thank you very much. Okay, well, hi there. I'm John Darrington. I'm the lead architect for digital engineering at the Idaho National Laboratory. I'm extremely excited to speak to you today. I constantly feel like I'm doing some of the most interesting work of my career right now. Hold on one sec. There we go. And it's a different beast presenting online, especially to such a large and diverse audience. I constantly I worry a little bit. I don't get stage fright because I can't see faces, but I think there are some special challenges when it comes to keeping your attention. It's so easy for you to minimize your window and browse Reddit. Enjoy that while it lasts, but stick with me though. I tried to find something practical, and I tried to find a title as catchy and as interesting as the stuff that we are doing at the lab. So just a quick blurb about me. I've been working with the Idaho National Lab for the last 4 years in their Department of Digital Engineering. We do a lot with data management, digital twins. Prior to that, I was working in the commercial area. I did a lot of international e-commerce data management work, international e-commerce transaction work, all of that jazz, and have been in the data management and API world for quite a long time. I also helped develop for the Idaho National Lab an open source data lake called Deep Links and various tools in that ecosystem. So let's go ahead and get started. Let's look at this picture here. Now the scale of this photo might be hard to see at first, but off to the left you can see this red line, and it's part of a crane truck. At the very bottom of that red line, you can see a little truck with its support arms. If you watched the news at all during a period in 2011, you might have an idea of what this is. It's one of the damaged buildings of the Fukushima Daiichi nuclear power plant in Japan. Now, the Fukushima incident in Japan came about, let's skip that, because a 15-meter high tsunami disabled the power supply and cooling of 3 of the Fukushima Daiichi reactors. And 3 of those cores largely melted in the first few days of the incident. And it took until December of that year, so later that year, to reach a cold shutdown condition into where they were able to get into the reactor and do the things they needed to do. And this was a big nuclear disaster. Thankfully, death counts stayed low to non-existent, with most deaths being attributed to the earthquake and tsunami rather than the nuclear disaster. So thankfully, it could have been a whole lot worse. But why do I bring this up? And I think it has to do with this, is that no industry is immune from accidents, but all industries learn from them. The Idaho National Laboratory has had a large part in nuclear history in the United States. It was at the heart of the first city run on nuclear energy in the States, Arco, Idaho, and has helped researchers learn how nuclear material behaves and misbehaves. So nuclear energy has basically had 3 large-scale disasters: Fukushima, 3 Mile Island, and of course, Chernobyl. From each, the nuclear industry has grown more and more adept at managing and monitoring the risks related to nuclear energy. It's not all roses, though. A safety focus, while extremely necessary and good in the nuclear world, has had some adverse effects on the software development industry, which supports it. So let's talk a little bit about the nuclear software industry state as I've seen it and as I've dealt with it in the last little bit. First, it's very risk adverse. When you're dealing with nuclear energy and you're dealing with nuclear materials, you are very risk adverse because you do not want to cause any incidents. You don't want to introduce new and unstable technologies. You want to avoid that. And because they're risk adverse, change is slow in the industry. And being able to create new technologies, new APIs, new software, and have those launched into the nuclear space can take a long time. For example, there's something called NQA1 certification for software, and it is very many pages long of regulations and rules that your software must follow, how it's designed, how it's built, how it's developed. And so it makes it very slow and very difficult to build new tech in the nuclear control industry. Everything feels like it's done in committees. And now this can be a good thing, but in a lot of cases, it does slow things down. You get a lot of politics involved with software and technology choices when it should be something that's looking more at the tech and what can work instead of something along those lines. And so things being done in committees leads to a set way of doing things this way because that's the way we've always done them in the industry. And I see that far more in the nuclear industry than I have in any previous industry that I've worked in, to where we do things one way and we stick with it and don't change it. And then the last, which is not an insurmountable obstacle, but is very difficult, is dealing with ancient protocols. I mean, we're dealing with very old code, very, very old APIs, ancient networking protocols, old binary file formats. And so when you're dealing with these things, a lot of the new tooling doesn't have software packages designed to create it. For example, LabVIEW's TDMS file format does not have reader libraries in very many languages, especially modern languages. And so it can be very difficult to read something in that file format. In fact, I've written a few to help out with that. So we're dealing with this. So this is where we find ourselves at INL, attempting to modernize the nuclear control and monitoring world with current tech and best practices while fighting decades of safeguards, some of which are either no longer relevant or were never more than a reactionary effort. Now, the next slide here, this is an original slide. So this is where we found ourselves. And so we decided that we needed to introduce a new technology into our work. And this is the original slide from a 2022 meeting. Don't pay too much attention to the word deep links here. We'll briefly touch on that a little bit later. But what I wanted to highlight here is that this original slide in 2022 is laying out the reasons why we decided that we needed to introduce new technology into the nuclear world and into what we were doing. So first of all, we were dealing a lot with Node.js, with a lot of our web-based services. But again, there's a lack of well-adopted scientific computing, at least at the lab. There's runtime requirements, so not really good for a low-level language. Python, again, has a runtime requirement. You can work with Python, but again, performance becomes a concern when it's not covered by the internal C libraries. It's permissive and allows for easy introductions to bugs. But my favorite bullet point off of this slide, and the one I kind of made a real push for, was the fact that we needed to make a conscious decision before the decision is made for us by accident. When designing your software or designing your APIs, conscious decisions before you're forced to adopt either a paradigm for accessing or a paradigm for displaying your data or anything like that is extremely important, because you want to control the things that you do, because the more control you have, the more powerful your software can become. And then the last bullet point here, which is safety and lower level languages necessary for operational control. Now, you might be asking yourselves, well, why do we need a low-level language, and why do we need operational control? What are we doing as a department that we need this kind of thing? And what we're doing as a department is building what you call a digital twin. Now, the digital twin levels, now these aren't comprehensive levels. This is just kind of a description. But I want to illustrate the fact that we move from this idea that a digital twin is just a model and some data connected to that model, so that the data and documents are kind of floating around and they're connected to maybe a model or something along those lines. And we eventually connect all that data, up through levels 3 and 4. But the culmination of digital twin work, or at least the culmination of an actual digital twin, is having a model that streams live data into it, that has predictive analytics on top of it, and then has a feedback loop into an operations control, so that the digital representation of this physical asset can interact with the physical asset that it's twinning, and be able to run changes, to be able to change settings, to do whatever you would have on there. And the culmination of digital twin work at the department is the eventual autonomous operation of a nuclear reactor, with controls and operations partially dictated by live and predictive analytics. This is a huge deal, and it was a perfect test bed for moving forward with our new technology, our new API paradigms, and just moving forward with this idea of the fact that we needed to change. Introduction of any new technology at a workplace is difficult. Introduction of brand new technology, at least by nuclear standards, into the control and monitoring systems of nuclear reactors can feel insurmountable. And we decided that if we were to express how these changes would serve us best, we would have to focus on the safety that such a change would offer us. Again, a stress on safety because of the nuclear engineering world. If we could convince them that this is a more safe move than continuing on with our current paradigm, then we move somewhere. So we decided to scare people a little bit first, do a little bit of a carrot and a stick, so to speak. our stick was memory safety and why safety matters. And so I'm not going to read all these bullet points. I think you're capable of reading these, or at least looking at it after the presentation. But when you're dealing with low-level hardware and monitoring systems, segmentation faults can mean the difference between disaster and safety, or between an experiment being scrapped, being decided that it's not useful, and then being successful. So we tried to drive home the idea that current software and current programming paradigms all suffer from a lot of memory safety issues, and they can lead to security vulnerabilities especially. And when you're dealing with classified data, or you're in that realm in the Department of Energy or the Department of Defense, you do not want security vulnerabilities. You do not want memory safety issues. And so again, it became a little bit of a carrot and a stick to help them understand that, hey, we have something here that can help you. And so once our focus became safety, the options available to us as technology became a lot more understandable. And we settled pretty quickly on one technology in particular. And you might know where this is going if you've dealt with this language before. This slide is, again, an original slide from that 2022 meeting. We were comparing different languages and technologies. We were comparing things like C++, Go, and then Rust. And Rust kind of stuck with us quite a bit. Again, it's sponsored by Mozilla, and some of this is inaccurate. And I wanted to maintain the inaccuracies so that we could maintain this original slide exactly how it was, so that you could see, into companies as they make decisions to shift technologies, what some of the presentations they might give are. But it's a statically typed compiled language. We can target all these different chipsets and OSs. You can actually run it without an OS. All you need is a memory allocator. There's no garbage collector. But what we focused on was the fact that concurrency is built in with an emphasis on memory safety in those concurrent operations. And that's exactly what we needed when dealing with nuclear reactors and digital twins. When we designed digital twins to bring in this data, when we designed these digital twins to interact with predictive and powerful analytics, we needed something that was able to be safe and concurrent. And again, this is not entirely accurate, and I think the community has grown at this point, but it kind of sealed the deal for us. And then what finalized it was this idea that we could interopt with other languages, because we're coming into the nuclear industry where we have to deal with various existing programming languages. We have to deal with C++, we have to deal with Fortran, we have to deal with a lot of Python code in our machine learning. And this idea that Rust could be interopted so that we could replace only pieces and bits and pieces of it meant a lot to us. And if you're ever familiar with something like the Strangler pattern, this idea that you slowly move things over into a new technology, well, Rust allows us to do that. And it allowed us to do that with existing technology. So within 3 months, we have a piece of software at INL called Deep Links. It's an open source ontological graph data lake with tabular and time series data support. I'm not going to spend tons of time on this, but it was originally mostly Node.js. And I think you can already see some of the problems floating up with dealing with data with Node.js, because it's a single-threaded language. It does not have good compute power, because you're blocking their event loop, so to speak, when you're doing high compute. And so we introduced Rust into it 3 months after our initial discussions, by building a loader for taking tabular data and loading it into Postgres concurrently and more quickly. And we got up to loading something like a 1 million row CSV with 15 columns of 64-bit numbers in something like 1.3 seconds. And so we were doing very good with loading this onto a single node, and Rust allowed us to do that. Rust also drove our time series and tabular data model and our Delta Lake integration. If you're not familiar with the Delta Lake technology, I highly recommend it for data integration and data warehouses. And then we've been working with Redis Graph to load our custom graph schema in Deep Links into Redis Graph so that we could use things like Cypher and a better querying layer than what we currently have. And then, of course, I don't think any presentation nowadays is complete without at least mentioning large language models. We are working with Llama RS, which is a Rust rewrite of the Llama C++ library for large language model solving. And we are looking at integrating that into Deep Links. And so we've done a lot with Rust. And we've done more than just Deep Links in Rust too. We have we have more than these two, but there's two other programs we have. One is called Serval. So another big cat. So we go back to Deep Links is a big cat, and then Serval is another big cat. And what Serval is it's a WebSocket multiplayer game server, drives our AR and VR multiplayer integration. So for digital twins, we have a visualization layer that's usually in augmented reality or virtual reality so that users can interact with our virtual twins. And then again, it drives another part of Deep Links. We also made a loader that was a Python and C# module written in Rust for caching time series and tabular data. It leverages DuckDB, another technology that if you're not familiar with, I highly recommend that you check out. And then it's utilized in many of our machine learning and AI pipelines at INL. Finally, after a year of experimentation with Rust with these new APIs, we were ready for the big time. This is the AGN-201 nuclear reactor. This is a fission nuclear reactor, and this model is rated for producing up to 5 watts of electricity. This particular model is located at the Idaho State University in Pocatello, Idaho, and is in active use. Not only do they have an active nuclear reactor, but that department also, I believe, has the ability to make their own fuel for the reactor. The NNSA and the Department of Energy asked Idaho National Laboratory to create and manage the first digital twin of a fissile nuclear reactor with this reactor as the target of the project. And this became a perfect test bed for our new technology and our new paradigms of working with this. So I wish I had more time to dive into Deep Links and our tech behind it. But what I wanted to show was that know that it, along with various other pieces of our Rust-powered technology, works in harmony to provide a cohesive digital twin of the AGN-201. Off in the right-hand corner, we had to push live analytic data from the data acquisition system of the reactor, some of this using 20 to 40-year-old technology, into the cloud. And once there, we had to organize and process it, bringing it into modern formats and setting it up for ingestion into various machine learning algorithms. And this was all done via Rust. We created a file watcher system on this particular system to deal with the file format. It pushes it into our Deep Links data warehouse, which then processes it and formats it and changes it into the right kinds of data. Now, while we are currently working on a comprehensive machine learning suite for nuclear engineering in Rust, we're actually rewriting an R library that we have created. We're not quite there yet, so we had to interopt with our Rust-based services and Python. And in order to maintain the speed, that's what we decided to do. We decided to write native Rust Python modules for this artificial intelligence and machine learning portion, that Deep Links loader that I mentioned earlier on, to work with this artificial and machine learning in that lower left-hand corner. And so once the data flows into Deep Links, it flows out into the machine learning algorithms, and we make predictive, we predict things on it. We have a neutronics model We can make predictions on how reaction's going to be, all sorts of different things that are very important for nuclear reactor operation. Now, up in the upper right-hand corner, this live model and human interaction is kind of the window into the digital twin. We used the same Rust code that we took and created a C# visualization. So in Unity, which drives our augmented reality and virtual reality. And by doing so, by just continually sticking with Rust, we were able to maintain speed and accuracy without having to move to socket-based communication or having to redo our software in each language for each of these disparate systems. And so we were able to maintain these things by using that. Now, our bet paid off. We successfully launched the AGN-201 digital twin in less than 6 months. Now, part of that is because the Deep Links data lake already existed. However, the technology we used to push to the data lake and pull from the data lake could easily be adapted to any of those existing data lakes that currently exist in the cloud or off speed. We were able to maintain speed and accuracy of data by using native modules and Rust. But the most important thing that we did, and what I want to stress here, is that we demonstrated the ability for Rust and current best software practices to eventually become part of current nuclear control instrumentation and paradigms. We were able to successfully demonstrate that, hey, what we do works. It's safe, it's powerful, and it gives you a solid API into working with a nuclear reactor that you might not otherwise have. And it was a very powerful system. And I want to finish up with very quickly with some lessons learned from this whole ordeal. And really, it's finding out what drives management, using those motivating factors to make that innovation happen, have a game plan, but most importantly, when you're dealing with new technology and new paradigms, is that you need to prototype early and often. The quickest way you can find out whether or not something is going to work for you is to prototype it. Get out there, get your hands dirty, build something that can take you onto the next level of your tech. That is the end of my presentation. Thank you so much. If you have questions, I think we have some time for questions, right? Perfect.
Yeah, we have 1 minute for a question. We went a little bit over time, but that was great. Again,
okay, thank you.
Extremely interesting. One question about, like, if you had to embed, because you talk about instruments, nuclear instruments. If you had to embed the software, like digital twins, we understood it's a parallel to the hardware, right? But
yes.
If you had to embed the software into instruments, would you still advise to use Rust for that?
It really depends on the instrumentation and the microcontrollers that you're dealing with. So if Rust can target it and can actually be compiled to work with that hardware, then absolutely. It is a very safe language. You're not going to run into nearly as many issues as you would be doing something in C++. But again, I mentioned earlier on that we have this idea of like ancient protocols that we have to deal with. In some cases, you might not have any other choice but to use an older language. But we are trying to move everything towards new modern languages whenever we potentially can. So
yeah, because at another conference, we got someone from NASA who told us, like, the most used programming language, or they still use Fortran or C, or
yes.
Because they say when we send something for 30 years in space, we need something that will be sure will be working for 30 years, right? So it has to be 30 years old. Yeah, So for nuclear, it seems you can go physically there at some point.
Yeah, and I think Rust is the programming language for the next 40 years. I think it's what we're going to send into space.
Okay.
To be honest.
Yeah, let's see. We will reinvite you in 10 or 20 years and ask for the prediction.
I appreciate it. Thank you so much.
Yeah, thank you very much, John. Extremely interesting. Thank you.
Thank you.
If you have any questions, we will relay them to you. Again, and so we continue with another leading forward talk about like imbibing sustainability into software development. So now it was software for energy, let's say providing and at some points long-term sustainability of energy. But now we will see the software aspect with Aman. So if Aman, hello Aman, how are you?
Hey, I'm good, thank you. How are you?
We're doing really well, and we're really glad to have you to talk about like how to make software more sustainable for the long term.
Yep, I'm really happy to speak to everyone today. Thank you. Awesome. Okay. So yeah. All right. Hey everyone. So my name is Aman Dhamija, and I'm really thrilled to speak to you all today about green software engineering and how we can imbibe sustainability in software development. So a bit about myself. I'm a software engineer at Goldman Sachs, and I was introduced to green software engineering through our firm's membership with the Green Software Foundation. And this is a field that I'm particularly passionate about because I think it's really great that there's something that we as software engineers can do to help with the climate crisis. It has been quite a journey of learning, and I'm really excited to share that with you all today. So let's get started. So, what is the Green Software Foundation? Well, it's a non-profit that's formed under the Linux Foundation with the mission of building a trusted ecosystem of people, standards, tooling, and best practices. The foundation's vision is to change the culture of how we build software such that sustainability becomes a core priority and is just as important as something such as performance, cost, or accessibility. And with net emissions increasing in the IT industry each year, it's very important for us to put software at the center of our sustainability discussions. But what is green software in the first place? Well, there are two ways of looking at software. Software as part of the climate solution and software as part of the climate problem. Now, we want to see software as part of the climate solution, and therefore we want to focus on reducing the carbon emissions from software. So currently there are only three ways of doing this: using lesser physical resources, using lesser energy, and using energy more intelligently. So essentially, green software is carbon efficient software, which means that it emits the least amount of carbon possible. So how do we go about building green software then? Well, it's important to understand the principles of green software and then put them into practice. So the principles are energy efficiency, hardware efficiency, and carbon awareness. Now, before we do a deep dive into these principles, it's important to understand the concept of carbon efficiency, which is at the core of all of these principles. Did you know that just 1 hour of streaming produces the same amount of carbon emissions as charging 7 smartphones? And so, for every gram of carbon that you emit into the atmosphere, you want to extract the maximum value possible. And therefore, a carbon efficient application emits the least amount of carbon possible. So, our goal should always be to be carbon efficient. With that in mind, let's take a look at our first principle, which is energy efficiency. Now, energy is the ability to do work, and it can exist in many forms. And we can convert one form to the other. So, in that way, we can actually think of energy as a measure of the electricity that's being used. But is our electricity even clean? Well, most people think so because whenever they plug something into the socket, their hands don't get dirty. However, most electricity is actually produced by burning fossil fuels, and therefore energy supply is one of the single biggest contributors to carbon emissions. And so if we want to be carbon efficient, then we must be energy efficient. So one way of improving energy efficiency is to understand the concept of energy proportionality. Now, I myself have been guilty of this, But I am sure that there are many people in the audience here who never actually switch off their laptop or their PC when they're not using it. And let me try to explain why we should avoid doing this. So essentially, the more that we utilize a device, the more efficient it becomes at converting electricity into practical computing operations. So if you take a look at this graph, let's assume you have a device which at 0% utilization consumes 100 watt of power. When it reaches 50%, it consumes 180 watt. And when it reaches 100%, it consumes only 200 watt. And so from this, we can see that the relationship between the electricity that's consumed by a device and the rate at which it does useful work is not linear. And so if we want to be energy efficient, then we must ensure that we extract the maximum utilization possible out of devices that are consuming electricity. Coming to our second principle, we have carbon awareness. Now, I know that we spoke about the fact that our electricity isn't clean, but how do we know how dirty our electricity is? Well, depending on your location or point of time during the day, electricity is actually produced from a variety of different sources, having varying carbon emissions. So some sources, such as wind or solar, are renewable, whereas others, such as fossil fuels, can be quite polluting. So let me introduce to you a term called carbon intensity, which basically measures the amount of carbon emissions in gram per kilowatt hour of electricity that's being consumed. And so if our goal is to build carbon efficient applications, then we must ensure that we utilize our electricity more when the carbon intensity is lesser. So carbon intensity varies by location. And this is primarily due to the fact that certain regions have an energy mix in which the proportion of clean energy is greater. It also varies by time, and this is due to the variable nature of renewables itself. So if you take a look at this graph here, you'll see that even though the demand for electricity remains the same, the carbon intensity of the bar on the right is much greater than that on the left. And this is because at that point in time, the wind may have stopped blowing or the sun may have stopped shining, causing your power grid supplier to rely more on burning fossil fuels to meet the same demand. So this brings us to a concept called carbon-aware computing. And this basically says, do more with respect to your compute when the carbon intensity is lesser. This can be achieved by a concept called demand shifting, which is possible when you have flexibility into where and when you can run your workloads. So one way of achieving this is by spatial shifting, in which we basically move our compute to a different location where the carbon intensity is lesser. Another way is by temporal shifting, in which we basically run our compute or our workload during a different time in the day such that the carbon intensity is the least. And doing this not only reduces our carbon emissions, but it also helps accelerate the energy transition to lower carbon sources in the future. Coming to our third principle, we have hardware efficiency, in which we examine the hardware that's used to build our software. So every device that we've come across has caused carbon pollution during its creation and destruction. And this is called the embodied carbon of a device. And it's actually a hidden cost when we want to consider the carbon emissions from software itself. So to put things into perspective, if you take a look at this graph, you'll see that for most end user devices, the embodied carbon emissions are actually much greater than the lifetime emissions from their consumption of electricity. So how do we go about improving hardware efficiency then? Well, it's actually quite simple. For end user devices, it simply means extending the lifespan of your device, whereas for cloud computing, it means increasing utilization. And to show you how much of a difference this can actually make, let's take a look at a few examples. So let's say you have a device which has 1,000 kgs of embodied carbon, and the expected lifespan is 2 years. That means you end up emitting 500 kgs of carbon every year. But if you were to just extend the lifespan of that device by 1 more year, then that would mean your carbon emissions would drop down to 333 kgs per year. And I really hope that this convinces you not to upgrade to the newest model of your smartphone or PC just yet. With respect to utilization, we can see here that it's actually much better to just run one server at 100% capacity rather than running 5 servers each at 20% capacity. And thereby, each server would actually contribute to the embodied carbon cost on an individual basis, which would add to the total, and we don't want that. So let's do a quick recap of what we've just learned. So the three principles of green software are energy efficiency, which basically says consume the least amount of electricity possible; hardware efficiency, which says use the least amount of embodied carbon possible; and carbon awareness, which says do more with your electricity when it's clean and less when it's dirty. Now, before we take a look at how we can actually put these principles into practice, let's try to understand how we can measure the carbon emissions from our software itself. So the Green Software Foundation came up with the software carbon intensity specification, which is basically designed to score your application along the dimensions of sustainability and encourage action towards elimination of carbon emissions. So basically, it asks to bucket the emissions from your software application into two categories. The first one is operational emissions, which arise from running your application. And the second one is embodied emissions, which basically are emissions that are happening from the hardware that's used to run your software. So if you take a look at this equation on the screen, the first term, E into I, represents your operational emissions, where E is the energy consumed by the software, and I is the location-based carbon intensity. The second term, M, refers to the emissions from the hardware that's used to run your software. So essentially, this equation becomes carbon per R, where R is a functional unit that defines how your software scales. So for example, do you want to calculate the carbon per number of end users, or do you want to calculate the carbon per number of API calls or per number of ML jobs? It entirely depends on how you define what the scaling unit is. So now that we've learned what the three principles of software, of green software are, and how we can actually measure the emissions from our software, let's take a look at how we can apply some of these principles into practice. So from a carbon emissions perspective, it's actually much better to cache static data such as images or audio instead of transferring them over the network, because the lesser the distance data has to travel across the network, the lesser electricity that's required to actually move it across, and therefore the lesser carbon emissions happen. Similarly, the embodied carbon cost also goes down because your data has to travel across reduced number of servers. When you want to deploy your application on the cloud, you should choose a region that's basically closest to where majority of your users are. And this is because the network traffic is reduced and thereby your carbon emissions also reduce. So now let's take a look at a case study whereby UBS and Microsoft came together to put into practice the concept of carbon-aware computing. So UBS has a core risk platform on which they run Azure batch workloads. And they basically wanted to see if they could use the concept of time shifting to reduce the carbon emissions from their jobs. So the Green Software Foundation has an open source project called the Carbon Aware SDK, which is essentially a web API and a command line tool that's capable of measuring and predicting the carbon intensity of a particular compute, given that you provided a location and a time period for which the compute will run. So they use the Carbon Aware SDK to calculate the carbon intensity of a workload that had already run in the past, which was essentially a job that ran for 15 minutes. This came out to be 719 grams of carbon per kilowatt hour. They then queried the carbon-aware SDK throughout the day at an interval of 5 minutes so as to find an optimal time window during the day such that they could run their job and the carbon intensity would be the least. And so the carbon-aware SDK predicted such a window, and basically the prediction for the carbon intensity of that window was 659 grams of carbon per kilowatt hour. Then they actually executed their workload during that estimated time window, and they found that the carbon intensity had actually reduced by 10%. And for their MVP solution, they focused on reducing the carbon intensity in their efforts to reduce carbon emissions from their overall job. So this brings us to the end of my presentation. And if you're interested in learning more about green software, then the Green Software Foundation and the Linux Foundation have launched a free course that can help you to build, run, and maintain greener applications. You can find more information about this on the Green Software Foundation's website. Thank you so much for listening to me, and I'd be happy to answer any questions you have.
Thank you very much. Thank you very much, Aman. Thank you for all of this. So at our London conference, we had Sarah Sue, who is a colleague at some point,
Yeah.
who were explaining us like the interest of the Green Software Foundation and what you do. So today, to your mind, what is let's say, what is the main sponsor of such initiative? Is it more the business? Is it more the tech side, the compliance side, or the ESG side of the company? Like, how does that work to implement?
Sure. I think this varies from like company to company. Particularly like for us, I think we're interested in kind of spreading awareness about this at the grassroots level, and we as engineers are really passionate about this. And we look at how we can use our learnings from the foundation and apply it into practice. But yeah, I think for other companies as well, they are conscious of their ESG efforts, and this is a very interesting space which can have a lot of impact, given that the software emissions are contributing so much to carbon emissions overall. So I think that might be an interest for many people to join this platform.
Yeah, totally understand. Also about the impact, sometimes there's always the debate, software versus hardware. So like, is it does the Green Software Foundation focus on just the software part, which is already something, or where the hardware is included, or if it is?
Sure. Yes. So the embodied, like the carbon emissions from hardware, which is embodied carbon, is a cost that is often maybe not seen at the first time when you think of carbon emissions from your software. But the foundation and especially this field that we're exploring encourages us to consider the carbon costs that comes from your hardware, which are actually very significant, and sometimes for end user devices even more significant than their lifetime consumption of electricity. So we have data sets that we're compiling that can basically tell us, for this particular hardware, this is the amount of carbon cost that you should consider when calculating the carbon emissions from your overall software applications. So yes, we would want to take into account the hardware as well as the software when thinking about emissions.
There's also a question about the storage or the network, or how do you decompose the runtime of the software versus the, let's say, what's around the software used, like the bandwidth or the storage?
Sorry, can you repeat that?
No, how do you count or calculate to consider what's around the software runtime? Like the fact that you're running the software, like network bandwidth or storage, long time storage, or like how does that count into the green software practice?
Sure. So whenever we want to actually calculate the carbon emissions using the SCI, we want to establish a software boundary basically. And so this boundary should ideally include everything end to end that's used to run your application. So yes, you'd want to take into account the emissions that are, from your storage devices as well as the network traffic as well. And we kind of want to use that into our calculations, and our effort should be to reduce everything within the software boundary when it comes to carbon emissions.
Yeah, perfect. Thank you very much, Aman. Thank you for answering the question. Thank you for being there and presenting us SCI and the Green Software Foundation. And looking forward to having you at another apidays conference.
Thank you so much for having me. It was an honor. Thank you so much.
Thank you. Enjoy your day. And so that's all for this morning. We have a 25-minute break, and we'll be back in 2 different tracks after the break. See you in 25 minutes.